You're going to start recording.
I'll let some people come in. Oh, shoot. I'm going to grab the instructions. Good morning, everyone. We'll be getting started in just a couple minutes. I have 7:59 right now. We'll get started at 2 minutes after the hour. Thank you for joining us. While you are joining, we would love to gain your feedback and insights on what analytical software do you use today. And to do that, please log into polev.com. You'll find the link in the chat box. Mark, is it there?
I don't see the link. I just see the, oh no, there it is. It's there. Okay.
Okay. And then enter in Jim DeVries 073. And then you will get right into the app. What I've done is put it on my cell phone and just open up a window on my cell phone. That's the easiest way to do it. With that, we'll see what you guys are saying. There we got some very common players. Of course, Sigma Magic, Minitab, Jump, Crystal Ball, MATLAB, Python, SAS, Simca, homegrown systems. If you're writing in machine language, God bless you. But for the rest of us, we generally use something to help us, unless we're real adventuresome. There we go. Thank you for entering that. Appreciate it. And we'll get started in 2 minutes. I'm sure Mark will keep me honest. So any thoughts on software packages out there? Mark, Suresh?
I guess I'm not surprised to see Minitab is the biggest one there, because that is the, they've been around for quite a while, have gone through many generations, many expansions of what they do. And but yeah, this looks about right in terms of Minitab, Excel, Crystal Ball showing up as the bigger ones, along with Sigma Magic. So
yeah, Minitab is generally, we used it for so many years. Everybody's comfortable to go back to it. It's easy once you learn it.
Yeah,
but,
the early versions back in the mid 90s, I would say, were not exactly user friendly. So
no, I think everybody's gotten a lot better user friendliness and for stats piece. All right, I think we're going to get started, right?
Yep, I think so.
All right, thanks for participating. Good morning, good afternoon, and good evening. Welcome to EIG's 70th webinar and the second webinar in this series, a discussion of our great experts, guest experts from the industry, Dr. Mark Sneeringer and Dr. Ramesh Jaraman from Sigma Magic. We're looking forward to an interactive webinar, and we look forward to your participation throughout. We appreciate your time in taking to join us in this webinar, and we hope that your family are safe and healthy. Again, this is the second webinar in our statistical analysis intelligence visibility series, generating data from informed decisions by making compelling decisions with variation-based data. The focus of our webinar will be to accelerate your ability to make informed decisions to solve problems in the most efficient and effective possible manner. Wouldn't it be great if an analytical software program could guide you through the right tools at the right time, helping you make better analytical decisions? Generating data-informed decisions is achieved by leveraging in deploying statistical tools and methods in the right order in the right time. So we look forward to your participation throughout the webinar. Again, please do log in to Poll EV and enter in Jim DeVries 073 so that you can participate in our polling throughout. And this poll will stay open until the next poll comes up. A little bit of background on myself. I'm president founder of Enhance International Group. And EIG is an exchange of passionate experts to guide your transformation to provide self-generating and self-funding results. We have over 50 consultants, consulting companies, and SaaS providers, and that have been vetted as best in class, including, of course, Sigma Magic. EIG serves as that master integrator to provide you the access to the best and brightest companies. We're like a Swiss Army knife. Our dedicated team is focused on empowering your organization's workforce by leveraging EIG's partner tenured thought leadership expertise. Our goal is to meet and exceed your expectations with customized, predictable, sustainable, and repeatable self-funding programs, providing you the competitive advantage. Today, we have with us both Dr. Mark Sneringer, who's an experienced continuous improvement leader with deep expertise in the Six Sigma, Lean, change management, and program management. Mark, a few words of introduction.
Yeah, hi. Yeah, I work mainly with businesses on process improvements with a heavy focus in the new product development area. I've been doing this for about 7 years, following a total of 33 years with GE and Philips in a variety of engineering, manufacturing, program management, and business process improvement roles.
Thank you, Mark. And we have Dr. Suresh, who's the managing partner of Sigma Magic and based in India, and he's a business transformation continuous improvement leader, highly skilled in Lean, Six Sigma, and project management, founder of the managing partner of course Sigma Magic Analysis Software, which has been downloaded and used for over 10,000 users. Pretty impressive across over 50 countries. So Suresh, a few words of introduction.
Hi, good morning. My name is Suresh Jairam, and I have more than 20 years of experience working for small and large organizations. I've been a Master Black Belt, a Lean Six Sigma deployment champion, a trainer and a coach for hundreds of continuous improvement professionals across the world. I'm happy to be here today and look forward to interact with all of you. Thank you.
Thanks, Suresh. Very exciting to have two experts in the field. Again, please do enter into the Poll EV throughout the webinar. We look forward to your feedback throughout. With that, we'll get started on the agenda. We have a 4-part agenda. We'll talk about Sigma Magic and the challenges of statistical analysis for the masses. Mark will kick us off there. Then we'll get into making decisions in the presence of variation. And then our third part is the power and simplicity of Sigma Magic. And then Sigma Magic's differentiating value we'll wrap up with. With that, Mark will get us started here with the challenges of statistical analysis for the masses. Mark?
Sure. So as we pointed out in our last webinar, statistical analysis tools have gotten more user-friendly over the years. However, there's challenges that still make it difficult for many people to achieve useful outcomes. So often these statistical tools aren't used even though the data are available. Decisions are getting made on based on averages or single numbers. So the more in-depth assessments that are possible if the variation of the data is taken into account just aren't happening. Next is the fact that most people don't use statistical tools on a regular basis. They never develop the proficiency to quickly select the right analysis. And when they do undertake one, it takes a long time to work through the steps as the user tries to remember, what they did the last time or what needs to be done. So this infrequent use often leads to using the wrong tool. So a key step in any analysis is understanding what your objective is Do I want to see if two samples come from the same population? Am I trying to see if an action has reduced process variation? So getting the objective correct is the first step. But even then, there are many seemingly similar tools, some of which could cause you to end up drawing the wrong conclusion. So this is sort of the dilemma. What we talk about on the next slide, though, is that Jim, the next slide. Yeah, okay. So so these occasional users would benefit from help setting up their analysis objectives and deciding what data to gather and how to utilize them. They also need help selecting the right tool and its settings for getting some error-free assessments. What we're calling analysis intelligence uses decision trees, wizards, clear, simple explanations, and other aids built into the analytical software to guide the user through setup, tool selection, and tool execution, increasing their speed and improving their results. Another help for occasional users, besides that, those wizards and stuff, is have a consistent layout and instructions for all the tools. So data are accessed in the same way from the single spreadsheet of tables. Input screens where options are selected look the same, and default settings are accurate for most analyses. And the user is notified when something is not correct before the analysis is attempted. The goal of this approach is to give the users confidence that they can use the tool, and they can use most of the, if they use one of them, they can use most of the others in that analysis program. So this analysis intelligence, as we call it, reduces errors and allows the user to focus more on their project and less on the software that they're using to get the answers. Suresh, I'm going to turn it over to you.
Yeah, thank you, Mark. So we are going to be using the Sigma Magic software to demonstrate how the software can make our lives easier and enable us to make the right decisions. Sigma Magic has all the tools you would need in your data analysis journey. The comprehensive nature of this software ensures that you don't need to jump between different applications to get your analysis done. All the tools have been designed from the ground up to be consistent into one logical structure. In fact, as Mark mentioned, if you learn one of the 100 tools, the rest of the tools follow a similar structure. So it's easy to learn and use for your projects. The logical structure for the analysis includes specifying the analysis options, the data for analysis, how you verify your data, and how you generate the outputs. The reason Sigma Magic facilitates analysis intelligence is because we have programmed how an expert would typically analyze a problem right into the logic of the software. So if you use the auto feature, you can just sit back and let the tool handle the analysis for you, or you can override the default settings and have more control over how the analysis is performed. The choice is yours. To set the stage for the scope of what we're going to be talking about today, this is a good slide that talks about the scope. We are currently excluding from our talk the big data analysis, where we deal with massive and complex data sets. We are primarily going to focus on those statistical analysis users for traditional small to mid-sized data sets. So within this segment, we are not going to be focusing on the newer state-of-the-art tech tools and technologies that research institutes and universities focus on. That would probably require a lot of programming and trying out different tools and technologies. Our focus is on tools that have been very well established in the industry for decades. These are powerful tools that have proven themselves in solving complex problems. And within this particular segment, we are going to be focusing on the ease of use and menu-driven architecture rather than the programmable interface some of the softwares provide, because the mass users may not be really comfortable with doing programming in order to do data analysis. Here is a screenshot of the tools that are available within Sigma Magic. You can use Sigma Magic for a wide variety of projects, including analytics, change management, graphical analysis of data, lean, continuous improvement projects, and statistical analysis of data. We will not be focusing on all of these tools today, but we will be taking a couple of these tools as a sample to illustrate our points for this webinar. Here is a sample screenshot of an input user interface for Sigma Magic. There are over 15 different control charts that are built into this single user interface. And you can actually change that in the chart type, which is sort of highlighted here, or you can leave it in auto and let the software pick the right tool for you. So as pointed out on this slide, the auto feature enables a lay user to actually use the more powerful, the logic-driven architecture of this particular tool and helps you pick the right analysis for the given situation. You could also use a flowchart-driven approach. So here's an example of a flowchart from Sigma Magic. So for example, if you're working with continuous data and your subgroup size is 5, and you can basically follow this particular flowchart and say, okay, yes, in this case, I'm going to use an X bar R chart. So either you can do it manually or you can let the software pick this for you. Here is a screenshot of the output or the analysis results that comes from the software. It includes both the graphical analysis tools and as well as the session window. The chart on the left shows the data points that are in control and out of control that you would typically expect from any analysis. On the right hand side, on the session window, you can see you have a summary of inputs. You have an automated checks that are performed to make sure that the analysis that it is being performed is accurate. And also there are analysis results and clear conclusions at the bottom, which helps you quantify the results and share it with your management. So far, we have basically covered a recap from the first webinar about what is Sigma Magic and how it helps us with our analysis. We're going to now get into the main part of our presentation, which is making decisions in the presence of variation. So the question is, how do people make decisions? In fact, we make thousands of decisions every day. Many of them are relatively inconsequential. For example, what should we have for breakfast? However, some decisions can be more complex and can have a significant impact on our life or business. For example, should we get into a new market? Should we invest $1 million to get into a new product or a service? So we are talking about these cases where we can have a significant impact and we need to take better precaution with respect to how we're going to make decisions. So on this particular slide, we basically talk about the different approaches people typically use to make decisions. The first approach that people typically use is the status quo approach. So it basically talks about, okay, people feel, okay, we've always done it this way, or why fix it if it's not broke? So actually not taking a call or taking too long to make a decision is also a decision and can have negative consequences for the company, especially if the status quo is the wrong decision. The second way that people might make decisions is based on random choice. This makes perfect sense when the stakes are low. For example, you have a bunch of people in your team and you need to break them up into multiple groups for an activity. And random choice helps avoid bias when you are picking the team members and everybody feels equally likely to participate in any team. So it avoids the bias issue. For example, who wins the lottery ticket is probably best left to a random choice. We can use this approach if you have limited time and the consequences are minimal and you can't make your decisions any other way. Of course, we're not talking about cases where we should be using this for more complex decisions. The third option that people use to make decisions is based on heuristics. This is something that they have developed over a period of time. So people feel that they have the expertise and they usually generalize based on their past experiences. For example, if you're driving on a road and you see a red light while you're driving, you instinctively hit the brakes. So heuristics are good because they are quick and they can help you react to a problem faster. But the problem with this approach is that it is not always correct. So a lot of people feel that they are very good at making decisions, but for complex decisions, this is probably not the right approach. Relying on them could result in incorrect decisions. There are several things that can creep in and make this a problem. For example, you could have illusory comparisons, inside bias, overconfidence, anchoring bias, and a lot of other things that can make this a bad way of making decisions. Anchoring bias occurs when we rely too heavily on the first piece of info that we get. For example, if you're targeting, we are targeting smaller companies, and the price of Sigma Magic is relatively at a lower price point so that the smaller companies can afford it. However, if a larger company looks at this particular product, they might feel that this product is inferior without objectively judging it just based on the price alone, because some of the competitive products are priced at, say, for example, $1,000. So some of these biases creep into our decision making and could negatively impact the way we make decisions. The fourth way that people make decisions is based on expertise. So this is not based on really heuristics, but there might be some cases where users are very knowledgeable about a particular topic, and the solution or the choices that they need to make seem very instinctive. For example, if you have an experienced sailor and he goes on a boat, he might just need little pieces of information like the wind speed or humidity to get an idea whether there's an upcoming storm. But if you have a novice sailor, they might need a lot more information like the choppy waters and so on to make it the same conclusion. However, because it's a subconscious process, it is very hard to teach others. So some pitfalls are your expertise maybe in one area and you feel that you are an expert, whereas you're making a decision in a different area, which might result in incorrect decisions. And finally, the best approach, especially when you're making complex decisions, is to use a rational decision-making process. This uses a methodical and a step-by-step approach to make a decision. It breaks up a complex choice into smaller, manageable chunks. It's easy to communicate to others and works well when the goals or variables can be expressed numerically. One limitation is that it might be tedious and time-consuming. However, for certain decisions where there's a lot at stake and data is available, it makes sense that we use this approach to make decisions so that more often than not, we make the right decisions.
Thanks, Suresh. Really well done on an overview on how decisions are made. And so with all these decisions being made, we have data, and you can collect it in two different ways: discrete or attribute data, or continuous or variable data. And we often ask ourselves what is available and what is the best. But we all agree that continuous variable data provides the most information about the processes. It can provide insights that yes/no discrete data cannot provide. This is why polls, discrete data, are generally in the order of 2,000 to 3,000 respondents across the different demographics, because we're trying to look at all the different demographics to get a fair sample. So it's always a balancing act of the demographics, getting all the demographics and getting enough data points. But we all know that 2,000 to 3,000 data points of discrete data can be addressed with 30 data points. But again, this is a demographic question as well as a number. But if you are able to sparse it down to the demographic of interest, 30 data points will show a lot more information, and it's rich in information, and it shows your process pain. So some examples: if you were looking at attribute data of yes or no data, maybe you might want to consider what is the difference between your target, your spec limits, and how you actually performed. And that could be in days or it could be in monetary. But the whole idea is, what's the difference between what you expect and what you received? How far away are you from that goal, that target? That's what's going to provide you a lot more information than just yes or no information. The same with the number or the percentage of defect or defectives. Again, defect is the overall, defects are the inputs of the process. Again, time and money to address and rectify the defect in type, that's the pain in your process. If you're able to capture that, you're going to be able to take much smarter action on that. in surveys, very often you'll do a yes/no survey, whereas you'll see 1 to 7 ratings, 1 to 5 ratings, 1 to 10 ratings. Of course, there are biases in them themselves, because people generally don't rate people below a 7. They think that's failing because that's how we were taught in school. So all of these ratings need to be developed into unbiased question. In summary, we want variable data, and variable data provides the linkage to process pain and how bad or good things are. And now Suresh will introduce some objective decisions under uncertainty. Suresh?
Yeah, thank you. So based on our discussion from earlier, let's assume that we have chosen continuous data as our primary metric. Even after we select the data, how we analyze the data is very important. A lot of times when we're making decisions objectively, of course, using facts and data, the most common approach used is to use a single point estimate for making our decisions. For example, we might look at the median home price, and let's say it's about $500,000. So we use that as a decision point to make decisions about whether to buy a home or not. However, it does not tell us anything about the variability of this estimate. It does not tell us what can go wrong with our analysis. For example, if you have a project that you're going to be working on, you calculate the NPV and you get it as, let's say, 100K. Should we invest or should we not invest? So this is a single point estimate for making a decision. And what it doesn't tell us is what's the probability of having a positive NPV. We just don't know with a single point estimate. So what we are recommending here is that instead of using single point estimates to make your decisions, you should actually be looking at the variability of your data in order to make a decision. All inputs have variation. Your heart rate, the stock market, the price of commodities, what time you wake up, everything has some variation in it. Hence, it makes sense that we need to be including variability when we are making decisions. So what should we do as an alternative? The next best alternative, Jim, previous slide, please. The next best alternative is, instead of using a single point estimate to make our decisions, we should be actually using a multi-point estimate. In this case, for example, we could be using best case scenario and the worst case scenario. This gives a little bit more information than just a single point estimate. So this does not give us an idea of what could go wrong, but at least it gives us a way to deal with it, with the worst case, but it does not get into the question of what's the probability of this particular event happening. And of course, the best way for us to make decisions in the presence of variability is to use something like a multi-correlation simulation. So this uses random variables and uses them to estimate the range of possible outcomes that mirrors reality. It also enables us to perform sensitivity analysis and to improve the quality of our decisions by considering the probabilities of success and failure. As an example, so let's take an example to illustrate our point. Let's say that we have two salespeople, A and B. A salesperson A reports an average of 25 units of sales over a period of time, while a salesperson B reports 30 units of sales over a period of time. So based on this data, we can basically maybe create a bar chart and we can compare them and we can say, okay, B is performing better than A. So based on this data, what do you think? Who should we reward? Should we reward person B for higher sales, or should we penalize person A for having a lower sale? In most cases, what we find is that people make decisions based on averages alone. So based on averages, we would basically conclude that B is better than A. So now let's look at the same problem, but include variability in our decision making. So here is some more granular data. On the right-hand side is a table that shows you the individual sales that were generated by person A and the individual sales that were generated by person B. Of course, the averages for person A is 25 and the average for person B is 30. So we have also done a box plot of these two data points, and that is shown on the left-hand side. We can see that person A has a lot less variation, a smaller standard deviation compared to person B. However, person A has a lower average compared to person B. So now the question is, who would you reward? Would you still reward person B for having a higher average? Or do you think that we need to be rewarding person A for having a lower variation? So how would you make your decisions and how would you pick which person should be rewarded? So these are the types of questions that we should be able to answer by considering variation as part of our decision making. Back to you, Jim.
Thanks, Suresh. Excellent explanation. And we'll kind of change, go up and talk about and give some folks some props here. Benjamin Disraeli of Great Britain in 1880 coined a phrase that we're all familiar. There's three kinds of lies. Lies, damn lies, and then statistics. And we know that one well. And then the second one is what this John Spacey put together in 2019. We did cover this last time, but it's just very compelling, the 17 misuses of statistics. And we're just going to highlight a few of them here and then show you some examples in a few minutes. So you have apples and oranges, comparing things that are not comparable, or using unfair, impractical criteria or comparison. In politics, we see this every day. Bias samples, poor quality examples, such as answers to leading questions is another area that we'll talk about. Data dredging, which is what we're going to get into here, looking for patterns in data using brute force methods that try a large number of statistical models until we get what we want. Another one is failing to mention controversial assumptions in your data. For example, representing a result in a particular IQ test as intelligence. So just pulling things out. We all see that all the time now. And out of context data, using data without understanding its context. We see that all the time today. And significant biasing analysis on statistical insignificant number of samples. So if we have insignificant number of samples, we make conclusions and we try to bias an overall thought that we're trying to prove. Or maybe we don't have enough data and we're just kind of wandering our way through and we're guessing. And we're a little bit better guessers than before, but at the end of the day, we're still guessing because we haven't taken the trouble to collect the data. So we're going to talk a little bit about how to collect data. This is from a perspective of a power plant or a manufacturing line where there's a ton of data out in most organizations, as well as in transactional systems. There is just a plethora of data that you have at your hands. And so we'll look at it from a perspective of if you were in a power plant, let's say, and you had continuous or you had a process plant, you'll be tagging data every 2 seconds. You're measuring, let's say, a steam flow or some kind of a flow, and it's tag-based zone data, and it's basically put into shift logs. And we see these offline reports. We have our shift reports, our daily report, daily production. You see this on manufacturing floors every day. And then they're rolled up into ERPs via BI and weekly or monthly. So what increment to do it in? And then you need to look at what do you have there from a segmentation type. What are the time frames? Do you have it minute? Do you segment and take your daily averages, hourly? We always hear about daily average performance. And as Suresh just talked about, looking at the average and the average of the average can yield subpar decisions. So we have to be very careful about what time increment we take it in so we don't fall into that trap. So we want to be able to segment the data and meaningful areas, different parts of the plant, operational modes, and operator roles and areas. Then from an event-based perspective, we want to look at, were there unplanned downtimes, planned downtimes? Was there inbound? Did we speed up the line, slow down the line? Did we do work orders? What did we plan to do versus actual? So trying to tie, again, that time increment data on the left with all segmentation and events. So it's tying all these things together will allow for our ability to make superior decisions from a tactical and operational perspective. So let's look at an example. So this is over, it looks like a few months, May in June, a few days here actually. And what you see here is steam flow. So if you're generating electricity, steam flow is pretty important. So the more steam you produce, the more power you produce, more electricity on the grid. So you're trying to maintain a targeted steam flow. You don't want to go too high because you don't want to blow up the plant. You don't want to go too low because you're not maximizing your power. So let's just say the goal is 300. And you say, well, we're doing pretty well. So if you look at it from a monthly perspective, as you see here, this is 1 month averages. I know this is a busy chart here, 1 month averages. So we're going to see how this changes for this boiler over time. So if you go to weekly averages, you see a little bit of variation. So you think the plant's running well if you look at it from a holistic perspective. Then you look at weekly and you see one thing. Then you look at daily averages, and now all of a sudden you see drops. Now remember, this is only when the plant's operating. If the plant's down, the data has been taken out. So here you have some dips. So why were there dips on those? So those were excursions you probably need to investigate. Now you look at it every 8 hours, you see a few more dips. And you see your major dips, but you also see a few other dips here. And we call those dips dense. And then as you go further and further, you see more and more. So then the question is, how fine do you go? Do you go hourly averages, 10-minute averages, or 1 minute? Now it's getting pretty noisy and you're going to go on like, I don't know if we can tell, can we make any conclusions? So coming up with the right time increment to make a decision is very important. Excuse me. That always gets me. Sorry. So we start coming up with the factor 10 rule, which we'll cover in the next slide. So in this particular case, what we found, just to answer the question, is that you can look at it from an hourly perspective to find your major dents. If you want to look at operational node data and find out what's going on from an operational perspective and really dig in there within the day, you're going to need to go to the 10-minute. Going to the 1 minute was just too noisy for us. So some best practices overall: the level of data consolidation should be consistent with your ability to make a decision and your ability to act on that decision to make positive action. That's the first best practice. Use the 1 in 10 rule to select the data collection. So if it's, as it says in this next next comment here, relate making an impactful decision to the time frame. So if you want to make an hourly decision, that's 60 minutes. You divide it by 10, you get 6 minutes. So 5 minutes, let's say, is the interval that you would want to be testing. If you do that, you're going to be safe. If you're trying to make monthly seasonal staffing planning, then maybe every 3 days. Again, 30 days divided by 10 is 3 days. So the factor 10 rule, it works pretty well as a thumb rule to get you started. Of course, when you look at the data, you need to refine that. Collect the data as detailed as you can in the beginning so that you can always build up to whatever time increment you're looking for. And don't fall into the trap of trying to smooth your data, taking the average of an average of an average, because that means if you're trying to hit a set point and you're focused on a target level, that means half the time you're not performing as your goal. If you make on average, you make your target. So just keep that in mind. And then again, look at your variation. The variation tells a story. Don't just look at what's going below, but going above. Very often we say, oh, everything below is a problem. Well, if you're going too high in steam flow, that's always also a problem, because a high causes a low very often as a scenario. So again, the overall best practice: an average of an average yields average results, which means subpar, translates into 50% of the time you'll be wrong on average. So again, watch out for averages. So what is the right level of consolidation for a decision maker? In this case, we said a plant manager. So this is a polling question. Again, respond in pollev.com, Jim DeVries 073, and enter in your answer. If you were a plant manager running this facility, what would be the right increment? What would you want to be looking at your data at? What time increment? Mark, Suresh, any comments?
So, I mean, this ties back to daily management sort of things. And so what sort of information is coming up through the tier meetings to that plant manager. So that's one of the concepts in terms of which I think would drive this sort of a decision closer to the daily or the shift as opposed to the weekly or quarterly, is the idea that a lot more people are using daily management in their operations.
Yeah, so it's in, I agree, it's in that daily shift area. Hourly seconds probably is too detailed. That's the operator themselves, from my perspective. Suresh, your thoughts?
Yeah, I guess it depends on the process that we are looking at and what decision we need to make based on that. So I think each process, of course, we have takt times, and I think within the lean, we have pace is something that we also compute in order to decide what is the right frequency of making decisions. So I agree with Mark. I think a lot of lean deployments are using daily management, for example, to monitor some of these processes.
Mm-hmm. So thanks everyone for your feedback and participating in the poll. And we just have some guidelines by role. I'll just go through them quickly, and because to get through quarterly, monthly, weekly, looking at things from a little bit different perspective. Daily, you're getting into your plant management and what issues are preventing you from making your goals on a daily basis. And then shift to, is more on that next level. And then hourly seconds is on the next level. So just as a guideline. But with that, I think we'll just move on to Mark.
Yeah, so years ago, I had a professor told me that data are like garbage. You have to know what you're going to do with them before you collect them. So expanding on that and expanding on what Jim and Suresh have just been talking about, following a defined decision-making process greatly improves the probability that you'll use these data that you've collected to reach valid and analytical conclusions. So these are laid out as 4 steps here. It can be other steps, but there's some key points here. The first one is that you need to define the problem. So you've got to make sure the scope is right and that you have a clear, agreed definition. An operational definition that covers the what, where, when, and how much usually helps you achieve this clarity. So once you have that objective, collecting the data is the next step. And you want to be sure to get those data at the source and in as much detail as possible, as you just saw from what Jim was showing. You want to be able to define not only what the central tendency or the mean or the average is of your data, but also what the variation is too. So then once you've got the data, then it comes to selecting the right analytical tool and getting the correct assumptions. That's what comes next. What are you trying to understand? Are you trying to understand variation, differences, trends? Do you have the right data to draw the conclusions that you need? And then finally, it's drawing those conclusions is helped by being able to visualize the data. So one of the first things I always do is graph the data. And then get into the statistical parameters such as confidence intervals and things like that. So this is a key point in proving your conclusions then, is once you have a conclusion, is going back and collecting more data and seeing if it still validates that conclusion. So this is just a generalized view of what you of sort of the steps of going through to get to a good decision. Suresh.
Thanks, Mark. So let's get back to the example that we were talking about earlier. So comparing salesperson A versus salesperson B. So to correctly answer the question whether option B or a salesperson B has an higher average compared to salesperson A, we actually need to follow the statistical methodology. So as we mentioned earlier, all processes have variation. So each time we collect the data, of course, we're going to get different numbers. So what we need to check is if the difference that we are seeing between salesperson A and salesperson B is because of random chance, or is there a real difference in the performance between these two salespeople? So in order to do that, we have an 8-step methodology for this particular problem of comparing groups. So the first step is to clearly state our null and alternative hypothesis, which is listed here. So let's say that our null hypothesis here is there's no difference between them, and the alternative hypothesis is that the mean for person B is greater than person A, which is what we want to prove or disprove. The second step is to determine what is the difference that we are practically interested in, how much of a difference would actually make something worthwhile for us to consider it as a viable difference. In this example, we have selected 10 as the difference that is of interest. The third step is to determine how much error are we willing to tolerate in our analysis, typically called alpha and beta errors. We have used the default values here. And the fourth step is to pick the test for this analysis. In our case, we are comparing the mean values for a continuous data set. So let's assume that we're going to be picking a 2-sample t-test for this analysis. The fifth step is to determine whether we have the right sample size and then collect the data in a random fashion without introducing any bias. So the quantity of data that we collect is very important. And it's also very important that the data that we collect is random and representative of the actual population. So this is a very crucial step. The sixth step is to determine if the data collected is normally distributed. If not, we may have to make some changes to the test that we have just picked. The seventh step is to check if the variances are equal, because there are different algorithms to use depending on if the variances are the same or different in this case. And finally, the last step is to perform the test and look at the confidence intervals and p-values and then make a conclusion. By performing all of these steps in the right order, we can conclude whether there is actually a difference between data sets 1 and 2. And we can also be assured that if we've collected the right samples and the right sample size, that we're not making more errors than the type 1 and type 2 errors that we have selected for this analysis. So based on the p-values that are listed here, we can conclude that in fact, option B does not seem to be better compared to option A based on the data that we have selected for this analysis. Hence, the correct conclusion in this case is there's no reason to believe that option B has an higher average compared to option A. So if you were doing this manually, you would have to basically follow all of these 8 steps in order to arrive at this particular conclusion. So now let's look at the case where we will be using a software, something similar to Sigma Magic, in order to make this analysis for us. So let's look at the power of Sigma Magic. So here are a few slides that talks about some of the different analysis tools that are available to us in order to make these comparisons. So I'm looking at comparing sets of data between each other. So in this screenshot here are different analysis tools available when you have continuous data and you want to compare the mean values between them. And on the following few slides are other analysis tools that are available depending on whether you have you want to compare standard deviations. So there are a bunch of different tools for that. And on the following slide, we have a bunch of different tools if we are comparing, for example, proportions, whether we're looking at defects or defectives. So overall, there are about 20 different analysis tools that we could have possibly used in order to make this comparison. And let's take a short survey now to see what are some of the tools that you have typically used in order to make comparisons based on your past experience.
So this is a rank order poll. And so what you'll do is you'll move things up and down the list. And what we'd like you to do is at least do sort of what your top 3 or 4 are, so that we can get an idea across the folks that are involved in this webinar.
Yeah, and we added, kind of group them a little bit more on equally distributed distributions, normal distributions, and non-normal distributions, and then some discrete data tools. So just choose what your top 4 or 5 go-to tools are, and just rank them using the arrow on the left. So if you highlight Levine or something, and you highlight it, and you'll just there'll be an arrow to the left or to the right, or to the left and up it, an up or down arrow. Just choose one of those to move it through. So some of the responses so far, it looks like a t-test, chi-squared, ANOVA. At the bottom, Man Whitney, I have to agree. I don't see that being used a whole lot. Suresh, Mark, your thoughts?
So yeah, I think it's pretty representative for what people usually use in order to make comparisons.
Mm-hmm. Yeah, ANOVA is probably one of the most famous tests.
Yeah, I mean, these are the things that as you're, learning this stuff as and you're first getting into it, ANOVA, t-test, chi-squared, those are the sorts of things that you pick up first, or you start using first. The others come along as I think you get deeper into it. So I think one of the values of having something like what's built into the Sigma Magic is if it drives you toward one of those ones lower down the list, that's a better test than what you would have done just based on what you know so far. So.
Excellent. Thanks everyone for your feedback. Very, very informative. And it's like Mark said, I think it's in the natural order that we teach, which is very interesting. Okay, with that, Suresh.
Yep, thanks. So just to recap from our discussion from earlier, so we need to be using these 5 steps to make decisions. First is make sure that we have the right metrics to solve the problem. Second, make sure that we have good data. Third is we need to ensure that we're using the analysis data that is sufficient for the analysis and representative of our population. Fourth is perform the analysis, ensuring that we have the right assumptions and model checks. And finally, draw the conclusions and share your results with management. And more importantly, what actions are you going to take to address your findings? So now let's look at how we would basically use the Sigma Magic software in order to perform this analysis. So here are some input screenshots that you would encounter if you were using Sigma Magic software. So there are basically four screens here. In the first screen, we basically select, okay, we want to do our data type is continuous and we want to compare 2 samples. So those are the 2 inputs that you would specify on the first screen. And of course, the comparison is mean or the median. We want to compare the averages. So this is our first screen. On the second screen on the right, when we want to actually perform the test, so the hypothesis test, we have left it at auto. So basically, we have asked the software to select the right test for us based on our inputs and the data that we have specified for analysis. The delta here basically shows what is the practical difference that is important for us. So in our example that we had 10 as our delta, so we have specified that. And we have not really changed the confidence levels and hypothesis test. The default values are 95% and 90%. So we let that be. The software will list the hypothesis that is currently performing. So in our case, the null and alternative hypotheses are listed by the software. The screenshot number 3 basically helps us pick the data for analysis. So in our case, we have data A and data B for salesperson A and B. So we've selected that for analysis under analysis variables. And the last screen at the bottom basically is a verification check from the software. It basically checks to make sure that you've correctly specified all the inputs for the analysis. So in our case, there's a green check, which basically means that everything is good to go. So when you click on OK button, it basically takes these inputs, performs the analysis, all the 8 steps that we just talked about, and displays the results. So here is a screenshot of what the results you would expect. On the left-hand side are a couple of graphs that are generated by the software. The first one shows you the p-value from this particular analysis, whether it's in the red or the green. and you have a confidence interval plot between A and B. And on the right-hand side is your session window, and it shows you the inputs for the analysis. And more importantly, you can check the assumptions here. So it's basically checking, is your data normally distributed? And yes, there's a check mark, which shows yes, the data is normal. It also checks whether the variances of the two populations are equal. It has found that they are in fact equal. But one check that has failed is that we do not have sufficient samples to make this decision. So it actually ran a sample size check at the background. And I think we only have about 12 or 10 data points, 12 data points, sorry. And you actually need about 14 data points. So actually we should have collected a little bit more data in order to control our type 1 and type 2 errors. So that is a warning for us here, saying that maybe the data is not sufficient for analysis. And the conclusions at the bottom, it does a two sample t-test, and the conclusions at the bottom, it basically shows that there's no reason to believe that the salesperson B is actually performing better than salesperson A. Maybe what we have seen is due to random chance, and the next time we collect the data, it's possible that we might have different set of numbers. So you can see that all of the different 8-step methodologies that we would have to do manually is pretty much done automatically within the Sigma Magic software here. The next few slides basically talk about a few other analyses. We only talked about actually making comparisons between samples as a part of this seminar discussion today. But there are a lot more other tools available within Sigma Magic that also has built-in analysis intelligence. For example, for control charts, for design of experiments, how you pick the model, how you do the model reduction, and for regression analysis, capability analysis, looking at the type of data, whether it's normally distributed or not, Monte Carlo simulations, and so on. So all of these different tools have built-in analysis intelligence that it uses to make sure that the recommendations that the software is giving you is accurate and you can trust the analysis results.
Okay, so there's another benefit to this analysis intelligence that maybe is not so obvious, but it definitely exists. And that is, as infrequent users make mistakes or get stuck, the expert coaches need to spend time with them to get them back on track. By having an application that helps avoid a wide variety of the mistakes, the expert's time can be freed up to deal with higher value activities. And then something to consider besides the expert's time is that there's a danger of poor analytical results leading to damage or even failure of entire improvement initiatives based on statistical methods. I mean, a mistaken conclusion is communicated up the chain of command, and decisions get made, and then somebody comes back, it's a wrong decision, and somebody comes back and says, yeah, the statistics failed us, when in fact we were using the wrong analysis. So if the leaders see enough of statistical missteps, they tend to distrust anything that comes from any such analysis. So Sigma Magic's consistent look and feel, and its auto select and its verify features help avoid a number or a lot of these mistakes. So this is just something to think about besides the actual get the right analysis. It's helping the experts as well be more effective. So,
and I can't help myself, Mark, because I've seen this happen so many times where management gets wrapped up in analysis that's been done in the past with poor data collection and or poor data analysis, and then the whole program suffers fantastic. I mean, to a big negative extent.
Mm-hmm. So just to wrap things up, we've hopefully shown you how an application like Sigma Magic can improve the decisions that you make based on data available to you, and this is just a recap of the the things that the software does for you in terms of guiding different aspects of what you're trying to do and doing some verification. So in the interest of time, I want to flip to the next slide just to give people an opportunity. So what the next steps is. So the next step is we'll hope you'll take a look and try the software yourself. You can find free 1-month fully functional trial licenses on the website sigmamagic.com along with lots of help files and lots of e-learning materials. If you choose to proceed, there are several licensing options available, including annual license for $200, where you will always have the most up-to-date version and support, as well as other licenses such as for academic users and for shared versions when it's multiple seats on the same license. Support goes beyond the help files and e-learning that I just mentioned to include free online training sessions for groups and a one-day response on any questions or issues, which this is often a lot less than one day on when something goes into the help desk. So we hope you've enjoyed this discussion on variation-based data and the decisions that you can make from them, and that you will try Sigma Magic and see how it works for you. So Jim, I think we'll hand it over to you to wrap things up.
So if there's any Q&A out there, we'll be very happy to answer any questions that you have. Please enter them in the chat. I think, Mark, you said you had a question out there.
Yeah, there's one in the chat, and this goes back to what you were talking about on that rule of 1 in 10. And it says, what if you can't capture data that meets your 1 in 10 rule? In other words, how do you compensate for that sort of a situation?
Well, there's a couple things. First of all, you start collecting it at that level because you haven't collected it in the past doesn't mean you can't collect it going forward. So that would be the first thing you would do. And then you would, go and try to do a Gamba walk. You'd really want to walk that process in detail, really, and understand what could go wrong. You can always do, and you always should be doing an FMEA in concert with this, and looking to the frontline people that are actually living that particular process to gain a better understanding. But unless you cannot collect data, if you're not going to be able to collect data, then you're going to have to collect other types of data, which is more survey and interview kind of data in the interim. So that's generally what I do. I don't know if you have any other suggestions, Mark or Suresh.
I think you start, if you can't get the frequency that your 1 in 10 or your decision timing says you need, collect what you can, and then start investigating ways to get more detailed or finer time cut data. But start with what you've got. That's the main thing I would say.
Yeah, I would agree with that. So I think sometimes data is available for projects, sometimes it is not. So I think if it is not available, we need to look at putting data collection plans in place. But in other cases where that is not possible, maybe we may need to look at other leading metrics that is leading into this particular metric and where the data might be available. So we need to sort of think about it. What's the best way for us to collect the data at the right frequency?
And very often it's manual collection of data where to get a representative sample. All right. Anything else?
Yeah. We're at the time. We're at our time.
Okay.
I'd
All
like
right.
to
So we can wrap up.
the use of folk. I'm glad people stuck with
so
us.
I'll just wrap up.
Let you wrap up, Jim.
Yeah, just to wrap up. Again, this webinar is the 70th webinar. You can find all the webinars on the website. Many of these folks have webinars listed. We have profiles on every one of these folks on our website if you are interested in looking at them further. And we cover people, process, data, and technology. Of course, here we're talking about data and analytics with Sigma Magic. Again, thank you for joining us with the webinar. Suresh, any closing comments?
No, it's great to have good participation here. Thanks everyone who attended this session. I hope it was useful for you.
Mark, any closing comments?
No, I'm good. This once again, I think Suresh is and Jim, you've taken us through some very interesting topics and concepts. And
we do have a raised
stuff
hand
as I go along here.
We do have a raised hand. VN, if you have a comment, can you enter it in the chat? I'll let you, I'll ask you to unmute if you want to talk. That's fine. Go ahead, VN. Go ahead. VN Brown. I'll let,
I think yeah, okay,
well, I mean, if he
okay.
wants to go on.
Yeah, I think we should just go ahead and,
All right, so if you do have
right.
questions, please feel free to send us your questions. We'll stay on if there's anybody who wants to talk, and we'll enter it in the chat, or we'll just go ahead and end the session. Thank you again. Appreciate it.
All right, thanks, folks. Bye-bye.
Bye-bye.
Thank you. Bye.